It's Dr. C, and today we will be going over how to calculate confidence intervals with proportions. So we have this question here where it says assume that a sample is used to estimate. So the important elements that we need to pick out, we're finding an 80% confidence interval. They gave us a sample size of 164, and then our proportion is 43.3. So if one had to write out the givens, it would be 80%. So if we're 80% confident, that distinctly means that we are 20% like not confident. So our alpha is 0.2. Our sample size given by the question is 164. And then our proportion of success would be 0.433, which means our proportion of non-success would be 0.567. So this is going to be Q, which equals 0.567. Okay, so the first thing we need to do is we need to actually calculate the critical value. And that's going to be, so P is equal to 1 minus alpha divided by 2. We're using 2 because a confidence interval is a range of values, okay? So we do 1 minus 0.2, 0 divided by 2. And that equals to 0.9. So we can either go, you can plug that in, that is your probability value. Once we do that, that means that our Z critical equals plus or minus 1.28. So the next thing you would do is you would plug your values into the confidence interval formula. Confidence interval formula is P hat plus or minus Z critical times the square root of P hat times Q over N. Okay, so at this point we have all the values. So my first advice would be to calculate the margin of error. Margin of error is just the Z critical times the standard error, which in this case is P hat times Q. So we're just going to plug in the values. Okay, P hat is 0.433 plus or minus Z critical 1.28 times the square root 0.433 times 0.567 over 164. So when we do that, so 0.433 times 0.567 divided by 164, you take the square root of that times 1.28, and that essentially gives us plus or minus 0.0495, 0.433. So our confidence interval, the upper bound, would be 0.433 minus 0.0495. And then 0.433 plus 0.0495. When we put that together, I'm going to put that over here. 0.433 minus 0.0495. That gives us 0.3835. And then the upper bound would be 0.4825. So if we had to write this, it says to write it in a trilinear equality. That's just going to be portion. Lower bound goes over here, 0.3835, and then the upper bound is 0.4825. Okay, so this would be your final answer. I hope that you found this to be helpful. If you have any additional questions, please reach out.